So we had a point of intersection here at 1, 6 here from letter D there, if you notice that. Let's go back and let's look at our picture over here. So if I plot 1, 6 on there, and I draw a line from that point of -3, 2 to that point now of 1, 6, that line there should be perpendicular to that line segment there should be perpendicular to our line of y equals -x plus 7. And that should be the shortest distance, that -3 to 2, that there should be the shortest distance there that I just drew there in blue. And that distance there is 4 square root of 2. So let's go through another one of these examples. It says find the distance between -2, 4 and the line -2x plus y equals -7. So again, you want to take that equation there and you want to put it in y equals mx plus b form. So let's do that. So I put it in y equals mx plus b form, and now I'm going to identify the slope. The slope of that line there is 2. What's the perpendicular slope? So a perpendicular slope is always opposite reciprocal. So what's the opposite reciprocal there of 2? Oh yeah, that's a positive 2, so ours has to be negative. And then the reciprocal there of 2, it's 2 over 1, you got to flip it and you get 1 over 2. So our perpendicular slope there is going to be -1/2. Now we have to find the equation of the perpendicular line. So we've got a slope of -1/2 and we're going through the point of -2, 4. So I'm going to use my point slope form. I'm going to put my x1 and y1 in there. I'm going to put my slope in there. Notice we have a minus, so let's change that to a plus. Distribute your -1/2 through. Bring the 4 on over. And there is our equation of the perpendicular line. So now we're supposed to find the intersection point between that line and between the given line. So we actually rewrote it there in letter A. Take those two equations and set them equal to each other, so you won't have any y's in them anymore. So now bring your x's on the same side, so let's add 1/2 x to both sides. I'm going to bring the -7 over on the other side by adding 7 to both sides. I'm going to also get a common denominator on the left-hand side there, which is 2. So on the left-hand side there I have 4/2 x plus 1/2 x gives me 5/2 x. And now I want to get rid of the 5/2 x, so I can either divide both sides by 5/2 or I can multiply by the reciprocal. The reciprocal there is 2/5. So on the right-hand side there we get 20/5, which is 4. So those two lines there are going to intersect there at 4 something. So let's find out what the y value is. So you can either put it into the perpendicular line or into the original line up there in part A. It's up to you. I'm just going to put it in part A there. So our intersection point this time is 4, 1. So now you have to find the distance between 4, 1 and -2, 4. So again, use your distance formula. So -2 minus 4 is -6 squared is 36. And then we've got 4 minus 1, there's 3. 3 squared, there's 9. Add them together, 36 plus 9 is 45. Now we can take the square root, so break it down. That would be 9 times 5, so square root of 9 times square root of 5. Square root of 9 is 3, so you get 3 square root of 5. That is our final answer, 3 square root of 5. I'm going to do another one of these. Again, find the distance between 6, -8 and the line y equals -2x minus 4. The slope of that given line there is -2. What's the perpendicular slope? It's opposite reciprocal, so it's going to be a positive, and then the reciprocal of 2/1 is 1/2, so it's a positive 1/2. What's the equation of the perpendicular line? Well, I have the point of 6, -8, and then I have the slope there of 1/2. Let's use that information to write the equation. So y minus y1 there is -8, equals 1/2 times x minus x1 there is 6. That minus and minus there on the left-hand side make plus. Distribute your 1/2 through. Go ahead and bring over 8, so subtract 8 from both sides. And there's our equation of our perpendicular line. Now we have to find the point of intersection there. So what you want to do is you want to take the equation there, up there in the given problem there, y equals -2x minus 4, and then the part C one there, y equals 1/2 x minus 11, set them equal to each other and solve for x. So I'm going to bring my x's over on one side. I'm going to bring my constants over, or integers over on the other side. So I'm going to combine my x terms over there. I'm going to get a common denominator, which is going to be 2. So I get -4/2 x minus 1/2 x gives me a -5/2 x. You can either divide both sides by -5/2, or you can multiply by the reciprocal of -5/2, which would be -2/5. So multiply my numerators, multiply my denominators over there, I'm going to get x equals 14/5. Go ahead and take 14/5 and plug it into one of those equations. It's up to you which one you want to use. I'm just going to put it in the first one. So I'm going to multiply my numerators and multiply my denominators there, so I get a -28/5 minus 4. To be able to subtract fractions there, I need to get a common denominator. Common denominator is 5. So we get -28 minus 20 all over 5, which is a -48 over 5. So our ordered pair there is 14/5 and -48/5. So now let's find the distance between those 2 points, which means the given one and this new one. So subtract your x's. Subtract your y's. We've got that minus a minus going on, so change that sign. So 6 minus 14/5, I'm going to have to get a common denominator of 5, and the same thing with the y terms. I'm going to have to get a common denominator of 5 in there as well before I can square them. So doing so there, I'm going to get 30/5. And then the second one there, I'm going to get -40/5. So 30/5 minus 14/5 there is going to give us 16/5. So now we can square the numerator and square the denominator there. So now we have a common denominator. We've squared everything. Now we can just go ahead and add our numerators there together. And I'm getting 320/5, so I can just divide that out. 320, oops, sorry, 320/25. So I know 5 goes into those. So 5 goes into 320 there, 64 times. I can take the square of the numerator, square of the denominator. I cannot leave the square root of 5 down the denominator, so I'm going to multiply the numerator and denominator by the square root of 5. So we end up there with 8 square root of 5 over 5. So I can find the shortest distance from a point to a line. So now you get to work on your 2-4 worksheet.